Okay, so we were talking about free body diagrams. This is a method to solve our numerical problems, okay, complex problem. Okay, so once more I told you, in this type of method what we do, we take one body alone separately, write the external forces on that body and write net force is equal to what? Ma. If body is accelerating, that system is accelerating. Not accelerating, then what? Net force is equal to what? 0, because Ma term becomes what? 0, right? So I am writing here what you do in this method. Take, okay, separate one body from remaining, okay, you put it alone, write external, we will not talk about internal forces here, only external force you have to stop, write external forces acting on that body, right? Right, third step is what? Write net force, okay, net force. So net force we can say two ways. One way will be, net force will be like x or y direction will be equal ma if body is what? Accelerating, okay. Yes, this will write if body is accelerating, right, or system, you should write like if system is accelerating, okay, because the body will be part of the system. If system is accelerating, net force will be equal to what? Ma. Yes, this can be in x direction, you are moving horizontally or you are moving vertically, you can write in vertical, okay. Yes, then net force will be equal to what? You write 0 if system is not accelerating, is at rest or moving at what? Constant speed, right. These are the three simple steps to write FBD of anything, and using this we can find some unknown things, okay, like the acceleration of the system or some contact reactions. That we will do all this step by step, okay. Yes, so let's learn. We have some contact force which comes when the bodies are in contact. So we are learning those 4 or 5 forces we have: normal reaction, tension force, spring force, these all we have to learn, friction force, okay. So one by one we are learning them. So first contact force we are learning is what? Normal reaction. Yes, we represent by what? N symbol. We learning contact force means what? Which come in play when bodies are really in contact, okay. So normal reaction always happens only when the body is in contact with what? Some other body or some surface, then only normal reaction comes. For example, there is a table or some surface, you put a block here and you say this is block of mass n, correct, no? Yes, so this block is in contact with this surface, so the surface will exert a normal reaction on this block, okay. This block will exert a force of this how much? Mg. Then the surface will exert a reaction of what? N. And we already learned Newton's third law that this N will be exactly equal and opposite to what? Mg. So how you can write here? Suppose you want to write this equation here, because this system is okay, this block is at rest, okay, rest. So how you write? N minus Mg should be equal to what? 0, correct. Ma, this term becomes 0, so N should be equal to what? Mg. So normal reaction in this case is what? Your Mg, correct. What is a very very important point about normal reaction, correct, it is always perpendicular to what? Surface, correct. Where the body is placed, this normal reaction is always perpendicular to surface. This is a horizontal surface, so exactly is what? Upward means perpendicular, this angle is what? 90 degree, right. Suppose you put an inclined surface, later we will discuss mainly in friction topic the inclined surfaces, this is a theta. You put a body here, correct, of mass m, correct. Then how the normal reaction look? Your Mg will act always straight downward, that is what your Mg, correct. So reaction should be like this way, perpendicular to surface, right, R. So we are writing what symbol? N symbol, yes. So that will be your normal reaction. So in this case normal reaction not equal to Mg, because they are not equal and opposite if you see carefully, right. Yeah, so you have to write the component of Mg perpendicular or opposite to what? N. So if you see later we'll discuss when it come to friction topic, that this angle theta, that angle also what, theta. So this component becomes what, mg cos theta. All we'll discuss little later. Okay. So in this case the normal reaction will be equal to n will be equal to what, mg cos theta, right. Here n is equal to what, mg. So depends upon case, and what is important, normal reaction is always perpendicular to what, surface, correct. So these are said, suppose they are at rest, this both example I gave at what, rest. Okay, yes. So this also at rest I am saying. Okay, now if any one of them are accelerating, then this n value will change, then you would write this formula. So I am giving you some example when like bodies are either rest or they are accelerating, then what happens. And the very popular case of this, there is an example of lift case which is very popular, where we learn normal reactions. Okay, so I am writing like lift case. Okay, yes, how normal reaction will change, that we understand with the help of what, lift problems. Okay, yes. Suppose first simple case I write, lift is at rest, or you say, or moving up, or you can say down also, with constant velocity. There is a lift. So either you can say that first case lift is at rest, or lift is moving up and down anywhere with what, constant velocity. Velocity constant means the acceleration of the lift will be what, 0. Clear? Yes. It means what, the acceleration of the lift is what, 0, first thing, right. Suppose I draw, this is a lift and some body is what's inside the lift here. There is a person in the lift, and we are interested the mass of this person, I am saying m. We are interested that what is the normal reaction exerted by this lift on this person, right. This is our question. So mg will be straight downward, normal reaction will be straight upward. So in this case we have two force only, because acceleration already we said 0. So n minus mg should be equal to what, 0. In this case the n is equal to what, mg. Means suppose you put a weighting machine here. Okay, the person standing on a weighting machine, then it will show the real weight of that person only. Okay, correct weight itself, which is what, mg. Okay, first case. Okay, lift at rest or moving up and down with what, constant velocity, means acceleration of the lift is 0. So net force is equal to what, 0, that you wrote. Okay, n 1 force minus mg is equal to what, 0. Let's talk about now this case. Suppose this lift start accelerating, again it can accelerate upward or downward, or it can deaccelerate also. Okay, second case we are talking, lift is accelerating upward, or I will explain little later that accelerating upward is same as what, deaccelerating downward, or deaccelerating or retarding, you say retarding, okay, downward. I will explain this. Okay, first let's focus on this. Lift is suppose accelerating upward, the same lift I draw again, and this is a person here. Okay, and this lift is accelerating what, upward, a. Okay, let's write forces acting on this person, mg downward, normal reaction upward, and this acceleration is what, upward. So how the equation comes, net force is equal to ma, right, is accelerating. So net force n minus mg is equal to what, ma. Net force is equal to ma, we writing here also wrote same thing, net force is equal to ma, or let's write is 0 here because not accelerating. So in this case n will be equal to what, mg plus ma. Normal reaction will be equal to mg plus a. You see that the normal reaction exerted by this lift is what, increased, because the system is accelerating, right. So you see in this case normal reactions increase. Suppose you put a weighting machine again here, the weighting machine will show the more weight than was the actual weight of the person, right. Yes, mg plus a, here weight we say the apparent weight we saw. Okay, apparent weight is what, increased. Yes. Now why I said that, okay, this you understood, accelerating upward, then what I said is what, deaccelerating what, downward. Deaccelerating. Suppose same picture I draw, and what I say like this one is become same case, So this is the same lift only, but deaccelerating means negative acceleration. Deacceleration retardation means what? Negative acceleration. Same force I write mg n here. Okay, so how we write equation here? Because this lift is now deaccelerating downward, it's moving downward. So which force is big? Mg is big. So you should write equation like mg minus n is equal to ma, but a is what? Negative here, minus a. So in this case we get mg minus n is equal to what? Minus ma, or n becomes what? mg plus ma, means we are getting same answer, mg plus a. Okay, you should not confuse like why I wrote here n minus mg is equal to ma and here writing mg minus n. It depends upon which direction your body is moving. That force is what? Big. Like here lift is accelerating upward, you say it, right? Right. So means your n force is big, that's why it's accelerating upward. So n minus mg is equal to ma. In this case I am saying the lift is what? Deaccelerating downward. Okay. Yes. Means your mg force is what? Big. So mg minus n is equal to what? Ma. So it comes same answer only. Your lift is accelerating upward, is same meaning as what? Deaccelerating what? Downward. Correct? Okay. Let's go to the next case. Third case we are talking. So lift has rest or moving constant speed we did, and lift accelerating. Let's make it lift is accelerating downward. Accelerating downward, or it is same as what? Deaccelerating what? Upward. Like here I said accelerating upward is same as what? Your deaccelerating what? Downward, right? So accelerating downward is what? Retarding or deaccelerating upward. Yes, in both cases we get the same answer. Okay, let's check it. Suppose I am writing accelerating what? Downward. What will happen? There is a person, okay, reaction upward and mg downward, and acceleration a is what? Downward. Let's write net force is equal to ma. So moving downward, correct? Na? Means this force is big. So you write mg minus n should be equal to what? ma. Accelerating downward. Okay. Yes. So in this case n should be equal to what? mg minus what? ma. N should be equal to what? mg minus a. You see it, the reaction is reduced. Normal reaction is what? Reduce here. Here you see it was increase. The same way if you put a weighting machine here, it will show your less weight. Your weight will be, apparent weight will be reduced. Correct? Na? The reading will be less than what? Your real weight. Here the reading will be more than the real weight. So same case as deaccelerating also upward, same case is moving upward with minus a. You write n minus mg is equal to what? Minus a. You get the same answer. Okay, weight is reduced. So apparent weight is what? Less here than the real weight. Okay, fourth case you talk. Suppose this lift is broken. Okay, the lift is what? Freely falling. You say like lift is broken. Okay, or you say freely, yeah, falling lift. Suppose the cable of the lift is broken, that will freely fall. When something is freely falling, we say the acceleration to the body is what? Simply acceleration due to gravity. A becomes equal to what? G. Correct? So look here, what will happen? This is the body here, and this is your mg, this is what? Your n. Alright, n is freely falling downward. What? Acceleration a is equal to what? Simply g. When something freely fall, acceleration is what? Simply acceleration due to gravity. So in that case, okay, let's write force directly here. So how you write here? You write freely falling. In that case, okay, I already wrote here. You can check it here. This case only. Okay, this case only, moving downward or freely falling. So you write like n is equal to what? Write mg minus a. But a is what here? Again what? Equal to g. So when you put here n, mg minus g, n becomes what? 0. Correct? When something is freely falling, the reaction will be what? 0. If you put a weighting machine here below this person standing on a weighting machine, the reading in the weighting machine will be what? 0. It will not show any weight because both are freely falling. So reading will be what? 0. Same thing if you take this body in the space, again normal reaction will be 0. You have a spacecraft and you are standing on the spacecraft here, then they say that if I put a weighting machine here, what's the reading in weighting machine? Again 0. Reaction will be 0, right? Because accelerations were there 0. Okay, suppose very rare case you talk, this lift is falling downward, is moving downward with very high acceleration. Suppose say lift is accelerating, this case I am talking again, okay, accelerating downward only. Lift is accelerating downward, but what is given that suppose this accelerating is what? More than what? G. Acceleration of the lift is what? More than G, is moving very fast, very high acceleration downward. In that case, this formula, if you watch carefully, n will be n G minus A. If this value is big, this term becomes what? Negative, right now? This term becomes what? Negative, right? mg minus A. I am saying A is bigger than what? G. Acceleration of the lift is more than acceleration due to gravity, and this term becomes negative, means is coming like your normal reaction will be negative. Correct? It means what happens? This person will not be here. In this type of cases, what will happen? The person will not be able to stand on this floor. It will be what? Here. He will be touching the top of the lift. So it will flying in air like that, or you can say it will stick to the top. It will move to the top. Okay, roof. Correct? He will not able to stand on the ground if this acceleration is more. Right? Yes. So these are all lift cases where the normal reaction is changing, so your apparent weight is what? Changing. Okay. Okay, if you understood the lift cases, then now we are talking about motion of bodies in contact. Means mainly we have to find again normal reactions between what? Bodies with ground or between two bodies, right? Okay, what happens here? Like some bodies will be in contact, like this is mass 1 and there is another mass you can put here, this is mass 2, right? This is called m1, this m2. Then they are just in contact, they are not stick together, they are just in what? Contact, they are not glued. Okay, so what you do, you have to push this system to move them together. Okay, you apply a force F here. Okay, correct, you apply force F here, so these two masses start moving in this direction. Okay, so they can be moving at constant speed or they may be what? Accelerating. Correct. So what they ask us, one question they can ask you, what is the acceleration of the system, and they can ask you what is the reaction between these two bodies. Means this mass will apply a force on this here, let's call it R, and that body will also apply exactly equal and opposite force, what? R here, reaction. So this reaction we have to calculate. Okay. Yes. So here now we have to use our FBDs. Let's see them, how to use them. Okay. So how we apply FBD? Very simple. FBD, I told you already 3 steps. Okay, that you have to cut one body from the system and put it along, write the external forces acting and find the acceleration and what? Unknown force there, right? Yes. Okay, first step is first to find the acceleration of the system. We have to find what is the acceleration of the system. Simply acceleration of system. What is the answer? A should be net force acting on this system, okay, by what? Total mass. Yes, this is a general acceleration formula, and now whatever steps we follow here, the writing FBD, this will be till the end of the chapter. Same thing we have to do again, there will be nothing new. The name of forces will change, sometimes tension force, sometimes spring force, but the procedure and the way of solving questions will be exactly same everywhere. Okay. Yes. So how to find acceleration of the system? Always finding system. Okay. Yes, is always net force acting on the system by what? Total mass. Okay, like in this case we talk what is acceleration, what is force acting? There is only one force F, that's all. Correct? Yes. No friction given here. Sometime friction will be given, that we will learn in the friction topic. Okay. Yes, right now we are assuming there is no friction in any equation. Okay, so only one force applied here, F. Okay, F. What is total mass? You write what? m1 and m2. This is the acceleration of the system first. Okay, done. Yes. If suppose friction is given, then we see the friction is always an opposing force. You have to subtract here friction force minus F due to this body F1, but due to this body what? F2. That we will see in the friction topic separately. Okay. Yes. This is the acceleration of system done. Okay. Now we have to write what? FBD to find. Suppose the question is this: find the contact reaction. This R we have to find. What is the reaction between these two bodies? Okay, so let's write FBD of M1. Suppose you are writing FBD of what? Mass 1. So how you writing FBD? You pick that body, this is your body M1, put it here and write forces acting on this. What force acting on this one body? That's your F one is what, reaction due to what, that body, that's called what, R, correct. So reactions always towards the surface, correct na? Between when you talk about two surface like this, okay, yes, and is accelerating in this direction with what, acceleration what, A. Now we wrote FBD, now write our equation that net force is equal to either MA or what, 0. Here is accelerating, so net force should be equal to MA. And how you write net force? Body is moving this direction, so which force is big? F is big, because body moving this direction we are saying. So F, we writing this formula, writing that net force should be equal to what, MA, right. So F minus R is equal to what, M1 into A. Force, this force is big because the body is moving in this direction we are saying. So F minus R reaction by is equal to what, MA. M is mass of that body, M into A, right. Yeah, we have to find what, R. So what is the answer? F R, I bring this side, is M1A. So now acceleration already we have found here, we can put that acceleration here. What answer will get? Look here. So R is equal to F minus M1 into A. A is here, which is what, F upon M1 plus M2. When we solve this, what you will see, you get like F into M1 plus F into M2 minus M1 into F by what, M1 plus M2, which give answer of what, this term get cancelled, okay. So we get M2 upon M1 plus M2 into what, F. This is the reaction between the two surfaces, right, these two bodies. Now what is interesting, this answer you can calculate same answer if you take FBD of this body also, because this reaction is equal here, right. This apply a force something on this which calling R, this also apply same force on this body, equal and opposite exactly, okay. So suppose same answer I am saying, reaction you can calculate if you take the FBD of second body. Let's see it, right. Suppose FBD of M2, second body you take as FBD, still you should get the same answer. How? Yes, you choose the second mass here, let's put it here, this is M2. What force are acting? Reaction force here what, R, and acceleration here A, no other force, that's all. This F was acting on this body only, you cannot write for this, okay. The forces we are really in contact, that only we writing here, okay, yes. So what is the answer here? You write like net force should be equal to what, MA. What is net force on this body? There is only one force acting, R. So R should be equal to what, M2 into A. Mass of this body is M2 into A. Now A already we have found, M2. A is what? Here, F by, so you get same answer, M1 by M2 into what, F. Look at this answer and that answer, exactly same answer. So it doesn't matter which body you are taking, we try to take always a body which has like less unknown things. But in this case we have only one unknown, R. So for this body also only one unknown, R. For this body also what, unknown thing is what, R, correct, simple case, okay. Now we will do, let's extend this, we take three bodies, okay, yes. So if you see an important pattern, suppose two bodies are there, you want to answer directly, this is a way to solve. If you want to answer directly, then how you will answer, what is the reaction between two bodies? Simply like you finding M2, second body, force is applied on the first body, then second body by total mass into what, force applied, right. But you should not remember like this, you should understand how to solve this, because same procedure till what, the end of the chapter, okay, yes. Suppose three bodies are given, like this is a body, question number 1, okay. I will give numerical example to also, let's understand first. Three bodies are there, so they are saying find acceleration R1 and R2. Suppose some question is given and three bodies are given to you, this is a body 1, body 2 and let's say body 3 here, okay. Three bodies are given of mass M1, M2 and M3 and some force applied, you can apply anywhere, here some force F is applied like this, okay. Then question they are asking, the system is accelerating with some acceleration A, that you have to calculate. Then you have to calculate reaction between these two bodies, first bodies, let's call name, this we call R1, then this also what, R1, equal and opposite. Between these two surfaces, let's call it R2, R2, right. These are the forces applied, right, reaction force. This and this, they are in contact, so they will apply exactly equal and opposite reaction on each other. So these two are in contact, they will apply again same reaction, but these two values will be different, could be same or it will be different, okay. So you are writing R1 here, then R2 here, okay. There will be one more body in contact here, then write R3 between them, right. Okay, let's solve. First step is find net acceleration of the system, net acceleration of system, which says that acceleration is what, simply net force by what, total mass. Same formula writing. Net force is only F acting here. Again, no friction here. Okay. Yes. So total mass what? M1, M2 and what? M3. This is what your acceleration of your system. Now we have to find R1 and R2. Two things are unknown. You can take this body as FBD because there is only one unknown R1. You can take this body also, there is only one unknown R2. But first you cannot take this body because there are two things will be unknown. R1, R2 are unknown. You can take that, but it becomes little complicated. Okay. So it's better to take what? This body or this body as first. So let's take FBD of what? FBD of M1 we are taking, correct? Let's write it here. So this will be M1. Here force applied F, reaction here R1 and accelerating this direction, the acceleration what? A, correct? So let's write net force is equal to MA, and this force is big because body moving that direction, so this force will be big. So F minus R1 is equal to M1 into A. I wrote directly, hope you understood. Okay, yes. So R1 is nothing but what? F minus M1 into what? A. So R1 is what? F minus M1. A already we have found here, F upon M1, M2 and M3. So when we do like this one, your answer comes how much? Okay, M1 term get cancelled, we get M1 plus M2 divided by M1 plus M2 plus M3 into what? F. That's the reaction R1, correct? Yes. Okay, now to find R2, you can take this body as FBD, you can take that also. Because this body now R1 we know, so only R2 is unknown, you can take that also, okay. But simple will be what? This body, because there is only one force acting R2, okay. Yes. So you are taking FBD of M3 mass. You take FBD of 3, then what you will write? This is your M3. What force acting? Reaction force R2 here and acceleration here, no other force. So net force is equal to MA. So net force R2 is simply equal to what? Just M3 into what? A. Okay, R2. M3, A already we calculated, F upon what? M1, M2, M3, all these we calculated, right? So that's your answer. R2 is what? Simply M3 by M1 plus M2 plus M3 into what? F. So understand the pattern. Suppose you are finding reaction here, right? R1, then how many masses are ahead of this? M2, this is what? M3, right? M3. So how you wrote in formula? Where I am finding? Okay, I missed something here. Let me correct that. I wrote like equation, I wrote little calculation wrong. This M1 into A. So M1 term get cancelled. I should write here M2 and what? M3. These are remaining. Okay. Yes, M1 term get cancelled. So reaction here you finding how many masses are ahead? This and this. So sum of their masses by total mass into what? Force we applied here. Right. This is a contact. Same thing here. You want to find reaction here. That's only one body here. M3 upon total mass by F. Okay. Yes. This same answer you will get if you take the FBD of what? This body also. So let me show it here somewhere. You writing, suppose you write FBD of M2 mass, then you should get the same answer. R2 we have to find, R1 already we have found. How it will come? Like this one. This is your M2 body, and here if reaction is R1, here reaction is what? R2, and acceleration here what? A. So you say that net force is equal to MA. So R1 minus R2 is equal to what? M2 into A. Body is moving that direction, so this force is big. This minus that is equal to MA. So here we have to find R2. R2 will be simply equal to R1 minus M2 into what? A. R1 we have calculated, which is what here. So it's M2 plus M3 upon M1 plus M2 plus M3 into F. That's what? Correct here. R1 minus M2 into acceleration, which is what here? F upon M1 plus M2 plus what? M3, right? We are getting exactly same answer. Look here, M2 term get cancelled, so it becomes M3 upon M1 plus M2 plus M3 into what? F. But this was little complicated. That's why you took this body as a simple, right? Because only one force unknown R2, right? Yes. So this is what motion of the bodies in contact. We are going to apply force on one body, all moves together. Also, what is important here? You cannot pull this system, right? Now, you cannot apply a force like that way, because the bodies are not like glued together. They are just in contact. So you always have to push this system. You can push from this side, you can push from that side. Doesn't matter, right? Yes. Okay. So we'll do some problems, numerical problems on these type problems. Bodies are in contact. Okay. Yes.